Today we're going to continue on the back side of your notes 17.1 graphs of sine and cosine functions. So you'll see about a little bit past halfway through the page, it says the definition of odd function versus even function. So we have a couple definitions to go over. First one is an odd function, and what it states is for all x in the domain of f, so again these are functions, f negative x equals the opposite of the function f of x. Basically what that means is there's a rotation around the origin. I'll show you guys that in just a second. So what that means then, we kind of did a little bit with symmetry in a couple chapters ago, but if I input, or if I have an x that is, let's say pi over 2, and the output is 1, then if I have an input that is negative pi over 2, then the output's going to be negative 1. This is what a sine function, an example of this would be a sine function. And I'll pull the graph up in a second to kind of show you why that is. And then the definition of an even function is for all x in the domain of f, f of negative x equals f of x. And what happens here is there's a reflection over the y-axis. And you can kind of see how that plays out in the sense of if I have an x value and it equals 0, what's going to happen is I'm going to have the opposite, and that it's going to give you the exact same y value. So an example of an even function would be the cosine function. Now, real quick, think about what a sine function looks like. We start at 0 and it goes like this, and we know it kind of continues that pattern. Pretend that's a lot better sine graph than what I have. But again, it's a rotation about the origin. So if I were to take this, if you had some tracing paper and you took this and you rotated 180 degrees, this right here would be a rotation right on there, and the whole graph would copy to the other side. Now, if we think about what a cosine graph is, it starts at 1, comes down, and comes back up, and again, the symmetry is going to the other side too. And with this, it's the reflection over the y-axis. So if I were to fold this in half right along that line, you could see that mirror image here versus here. So again, an example of an even function is cosine. An example of an odd function is sine. Now, what I'd like you to do in just a minute is I would like you to go to Moodle, and under chapter 16-17 there is an amplitude link. So again, you're into chapter 16, scroll down, and you will find amplitude trig functions Desmos. I'd like you to click on there, and when you get there, you are going to see something similar to this. Now I know it's cut off a little bit on the side. Let's see if I can move it over. Not quite. But it shows the graphs right here. Let's see if I can show you a little bit more. And so right here, the red, you can see the sine graph, and the orange, you can see the cosine graph. Now, one thing that you will be able to do is if you go over to the circle, you'll be able to click off so you can see one at a time. And what I want you to do is I want you to pause the video and I want you to play around with those numbers, okay? And I want you to notice that only the number in front's going to change. And when you feel you've actually understood what that number, that coefficient in front does to the entire graph, then you can go ahead and resume the video. Okay, so I hope you did that for a little bit. And what I hope you understood what happened was, as right now, normal coefficient is 1 in front of a number when you multiply it. But when you move that, what happens is you could tell that the peak started to rise. So, and then when we got to 2, or 2.3 in this case, you can see that red line raised to 2.3. That blue line represents just your typical sine graph. And you can see how that peak kind of got multiplied. Now if I went all the way up to, let's say, 7, if I can get it right on 7, there we go, that peak would have a height of 7. But also, hopefully what you realized is it wasn't just the highest point that happened to, it was also the lowest point. So you see how that kind of got multiplied both out there? Notice everything else stayed the same. So if you look at this, I know this here, let's bring that red down a little bit. And actually, I'm going to get rid of the regular sign. If we look at the red graph, sorry, the pen keeps moving it. If you look at the red graph, and it starts still at 0. Being sine, it starts at 0. And it still kind of had that same flow to it. It went up at about pi over 2, and then pi over 2 came back down. And notice at pi, can you see that right there? At pi, it hit to 0, and then back down again, and then got back up at 2 pi. And it's at 2 pi that this starts repeating. Again, that's the period. So the period of the sine graph didn't change, only these peaks changed. Notice that center line 2 is still at y equals 0. So that middle line didn't change. The only thing that changed was that peak. Where it hit remained the same. Now, if I were to do negative, say, let's do -5. And let's put that graph back on there, that sine graph. Notice that blue one is at a positive one, but it got reflected to negative. So again, it's stretched, but it's stretched in a negative distance. So normal sine graph, again, goes to 1. But if I put a as negative, it would reflect and go to -5. And then same right here. Again, the period did not change, nothing else. You can kind of see that there's 1, 2, 3, 4 parts to it, kind of going up and down. So how would you graph something like this? Well, there's a couple ways that we can look at this. So in the first example, I know the graph got cut off on your page, so just flip to the next page. But the first graph that we have is y equals 1/2 sine of x. And we also are going to graph the y equals sine x and just kind of compare. So I kind of do this 2 different ways. I'm first going to make an x-y chart, and I'll kind of show you why. Because we want to see how it affects the x and the y values. So if you remember a sine graph, and let's make this 0.5 again and this 1. Remember that sine graph kind of has a pattern where, you know, it starts at 0 by 2 pi, it comes back down. At pi, it hits in the middle, but it's going up all the way to half, comes back down. Hopefully yours is a little smoother. It's a little bit hard with this pen. Comes back down like this. And I want you to see something. There's really 4 different sections. There's 1 section, 2 section, 3 sections, and 4 sections. And we talked about this earlier, how it refers to quadrant 1, quadrant 2, quadrant 3, and finally quadrant 4. But you can see by the red line that there's 5 different dots. The x values were at 0, then at pi over 2, at pi, and then 3 pi over 2, and finally 2 pi. So again, you can see 5 markings I made. And I'm going to do that with every single time that I do graph. Now, the values were 0, 0, and then at pi over 2 it was 1, and then at pi it was 0, and then 3 pi over 2 was at -1, and then finally at 2 pi it was back at 0. Now, with this half right here, this right here refers to, we'll say, letter A, and that, the definition of that is an amplitude. And that's how far it stretches vertically from the center of the graph. So typically the amplitude is 1, and you can see there the stretch is 1 from the center of the graph. This time though, the amplitude is half. So again, I'm going to show you 2 different ways you can kind of approach this. One, I can just visualize it. I know nothing else changes in the amplitude except for those peaks. It's going to be half the distance. So I put half there, and then I know it's going to hit at the center. So I'm going to just sketch it here, here, and here. Again, we should probably do 2 full kind of graphs of this, which is called 2 periods of this. So kind of wavelengths. And then again, I'm going to go back over. I know that that amplitude is half. So I'm cutting it in half each time, hitting the zeros because it's going to go back down. So then that green represents y equals 1/2 sine of x. Now, what does that mean for the t-chart? Well, hopefully you guys kind of understand this. What's happening is that the y values got cut in half. So the x values didn't change. Those markings still remain the same, but what happened is it affected the y values. So what happens is if I'm filling in a t-chart, I'm multiplying those y values by a, which is multiplying by 1/2. So 0 times 1/2 is 0, 1 times 1/2 is 1/2, 0, negative 1/2, and then finally 0. And if I were to plot these, 0, 0, right there. Use a different pen. And then pi over 2, 1/2, that's right there. Pi 0, that's right there. 3 pi over 2, that's negative 1/2. And then finally 2 pi, that's 0. And then I just connect them. So for right now, when you're doing this, I would like to see the charts along with, you know, you getting used to plotting the graphs.